Hello, welcome to Vertices Math. Today we're going to be going over an intro to graph theory. If you haven't subscribed already, hit that subscribe button now and make sure to turn on the little bell so that you get notifications for new videos. All right, so let's jump right into it. So with graph theory, you're not looking at traditional graphs such as graphs on Cartesian planes. These are not graphs of functions. They are kind of these little, they almost look like little webs sometimes. They're little dots connected by lines, and those lines represent something. So we're going to go over the different types of graphs and the definitions that go with them. So first of all, looking at a graph, you have these vertices. Sometimes you may see them referred to as nodes. These are things, they represent things. They could represent people, they could represent objects or cities, places, that kind of thing. So we'll just write that in there. So these are called vertices / nodes. So it really depends on the source you're using, the workbook or textbook, when you're learning this. So there is a little bit of overlaps in terms of notation in this topic, which can be a little bit frustrating, but you just go with whatever your course is using, whether it's vertices or nodes. I'm going to stick to vertices since that's what my students are comfortable with. So these are all vertices, and they're connected by what we call edges. So here an example would be you have edges are AB, and you can write that as AB or BA. Both of those are correct. It's describing this edge here. One way or the other, B and A are connected, and the direction doesn't matter in this case. There are other graphs where the direction of the connections do matter, but this is really just the introduction step, so we're just looking at basic notation right now. So we have the edge AB, we have the edge BC or CB, and we have the edge CD, DC. So that's these three edges right here. And then E is a vertice as well. So if we want to list all of our vertices, we would say we have vertice A, B, C, D, E. So this goes into the next little bit of notation where the way that you would describe a graph without actually seeing the picture. So the way that you do that is you have S that represents the set of elements within your graph, so all of your vertices. You use a little curly bracket and you just list those vertices. So I'm just going to pick this up right here, put it in there. And I'll draw a little arrow so we know that that's our vertices. And then to describe our graph, we list all of our edges. AB, BC, CD. So you can know exactly what the graph looks like or have an idea of what the graph looks like just by looking at this over here, because it tells you, well, I have 5 vertices and I'm going to have 3 edges. So I know that there's going to be 3 connections. I know that there's going to be one left out on its own since E is nowhere listed in these connections. So that's a way that you can look at your graph or describe your graph. Okay, so then the next little bit, we're going to look at definitions of, I should have put more space, I kind of made it a little difficult for myself. Okay, so we're going to look at the order of a graph. and that corresponds to the number of vertices within a graph. So for graph 2, your order would be 3 because you have 1, 2, 3. So order of a graph, that's number of vertices. So we can put a little note. This is order 3. Graph 1 would be order 1, 2, 3, 4, 5. Okay, and then we also have degree of a vertex. So degree of a vertex. So degree of a vertex is how many edges meet up at that vertex. So you're kind of looking at all of these lines and how many lines are kind of leading in to this vertex. Number of edges that meet at a vertex. So I'm going to keep pink associated with degree of vertex. So we're going to look at all of these vertices in vertices, I should say, in graph 1 and 2. So we'll just zoom into graph 1. So here, A has 1 edge leading into its vertex. So A has a degree of 1. B has 2 edges leading in, so it has a degree of 2. C also has 2. D has 1. E has no edges leading into it, so it has a degree of 0. So that was for graph 1. We'll take a look at graph 2. Here, vertex 1, that has a degree of 2. Vertex 2 has a degree of 1. And vertex 3 has a degree of 1. Okay, so now we're going to take a look at graph 3 since that has a little bit more going on with it. And we can talk about more interesting stuff here. So for graph 3, we have our vertices, we have our connections, and now we have some kind of funky stuff happening. So here we have this line that's been denoted by number 1, connecting K and J. And then we have this other line denoted by number 2 that also connects K and J. So this is what's called parallel edges. And they're parallel because they join 2 of the same vertices. So parallel edges are edges that join the same vertice. So if I wanted to do that same thing, so what I did over here, and describe my set of elements within this graph and then describe all my edges, the way that I would do that in this case, so we'll do that here, our set, so here we are listing all of our vertices. So we have K, J, P, M, and R. And now, to describe our graph in terms of our edges, well, we have to be specific and let the person know that there's 2 lines that connect K to J. And the way that we write that is we write K1J, meaning I am traveling from K to J using this first connection. K2J, which means I'm describing this edge instead, going from K to J using number 2. We have JP, we have PM. So that describes this is JP, this is PM. And then at M, we have this little circle, which is what we call a loop. So a loop is an edge that joins a vertex to itself. So this we would describe as MM, since you go from M and you travel back to M. So we'll put all of this terminology in here. So this here is a loop. And we have R all by itself. So now we're going to do those 3 things in describing this graph. So first we're going to look at the order. So again, the order is the number of vertices within the graph. So here we have 1, 2, 3, 4, 5. 5 vertices means that this graph is an order of 5. Now I'm going to switch to pink and I'm going to go and list the degree of each of my vertices. So I'll just zoom this in. So K has 2 edges leading into it, has a degree of 2. J has 1, 2, 3 edges leading into it, so it has a degree of 3. P has 2 edges leading into it, has a degree of 2. And M has a degree of 1, 2, 3. It has 3 edges leading into it. So a loop will always count for a degree 2. And then R has no edges, so it has a degree of 0. So that's our order. Those are our degrees. Yeah, and then we looked at our parallel lines and we looked at our loop. Okay, for graph 4 and 5, I want to talk about the difference between what is called a connected graph and a disconnected graph. So with a connected graph, you need to be able to get from one vertex to any other vertex without kind of taking your pen off the graph. So there has to be, it doesn't have to be a direct connection. You don't need to be able to get from G to H in one step, but you do need to be able to find your way there. A disconnected graph is kind of in 2 pieces. So you have this one piece over here, and then you have this piece over here, and there's no way for you to get from 5 or 4 or 3 to 1 or 2. There's no bridge that connects them. So here we're going to write disconnected graph. Graph is in multiple pieces. Connected graph. Well, I won't really write a definition for that. It's just graph is not in multiple pieces. I think we get the picture. Okay, moving on to the next part. We have graph 6 and 7, and what I want to show here is what's called a complete graph versus an incomplete graph. So a complete graph is kind of the final form, the evolved form of the connected graph. Because a complete graph has all possible edges. So from O, I can get to any edge. There is no missing piece within this graph. all the edges that could exist are there. An incomplete graph is a graph where there is at least one set of vertices that are not connected to each other directly. So I could get from A to C by doing kind of this long journey from A to D to C or A, B to C, but there is no direct route from A to C. And because of that, this graph is incomplete. And then there was one last thing that I wanted to talk about. Yes, simple graphs. So a graph is called simple if it does not have parallel edges or loops. That was the last thing on my list. So a simple graph does not have loops or parallel edges, which means graph 3 is not simple, graph 1 is simple, graph 2 is simple. And I think that wraps up our video. All right, so come back next time for paths and cycles. Bye-bye.